Hi and welcome to Multi-Tenant Splunk, Pitfalls from the Pit, version 2.0, updated for 9. My name is Steve Bochniewicz. I'm a security architect and Splunk architect. This project has been a long-running series, building on the work of others, and as well as some of myself. So here are a list of some of the talks that are available. Some of these are unfortunately no longer available, but I still want to reference them here for people who may be able to find them. Splunk as a service. The environment I work in, we run Splunk as a centrally managed solution for a bunch of decentralized IT services departments, potentially about 122 different customers, sharing one large Splunk environment. Splunk Base. Friend or foe. Splunk Base is not designed for multi-tenancy. It's designed for getting data. And Splunk, unfortunately, just like with everything, it really is just kind of a spread the data wealth around. Everyone gets a little bit. Many apps have searches and lookups that will run a system, which are available to any user that you've allowed access, and will eventually run and see access to all indexes. This isn't very secure. The apps are great for a starting point. Use the views and dashboards, and watch out for lookups, static index definitions, and other safe searches that are scheduled and designed to run. Apps are also great providing SIM mappings and other field extractions, but that's it. What have we done? Well, we automate all the things. So we were heavily environment in AWS. We have used CloudFormation and Puppet. Basically, it allows us to automatically create indexes in our Splunk environment when we build new CloudFormation, when our department deploys new application stacks. So this is a hands-off approach for us for Splunk, so everybody gets onboarded. We also use templatized apps for our departments so that all of their search and their environments contained. And we use the client name feature inside deployment client config to allow us to define department-specific as well as technical add-ons and other services that an environment builds. So what have we done? The next part, really the most important part with everything, is getting a naming convention down. Picking a naming convention that you can standardize and use throughout your environment and use is really important with Splunk. Everything ultimately relies and dependent upon names and structures, so it's really important to get those handled. In our environment, we use underscores as a delimiter to define the differentiation between our divisions, our departments, and our subdepartments. Subdepartments can be an n number level of subdepartments. The next part is important from my perspective. I don't want to have to be in the business of having to manage roles in Splunk as well as outside of Splunk. We use SAML as our shibboleth as our single sign-on environment. And so you assert your roles to Splunk to allow the Splunk to know exactly what role the user belongs to, and there's no additional mapping that required to be managed. We create custom apps for each department. Those roles that we build for those users, there's a separate role for read and write, a separate role for indexes, and during those index roles, we use wildcards, so we can easily add on new indexes and don't require to be updating or maintaining the departmental levels configurations for those apps. Additionally, we create custom privilege roles for the commands and features that we use. This allows us to give access very specifically to the features and services inside of Splunk at a granular level. How we do that? So we created our departmental apps. In departmental apps, we have the default meta. The default meta is the configuration template inside of an app. It defines who has access to what. So in our case, we basically define here the read and write accesses to those apps. We define, in this case example, the actual users, the roles that belong to the read roles and the write roles, as well as we create a special group we call our application management group, or A_MGMT, for managing the apps. This allows us to give a group that's responsible for knowledge workers to be able to manage apps without actually having to have access to the content or the indexes that feed those departmental apps. The next thing is we set the user preferences. We do this to ensure that the users correctly land on their departmental apps, and so that's where they operate from, and that's where their searches are saved and recorded to. The next thing is authorize. Authorize.conf is where the actual roles and definitions are created. Those roles there we see the read role and the write role. Fortunately, these circumstances, the way that, because authorize.conf is designed for capabilities and permissions, generally speaking, it doesn't do anything with application roles. So in your case, it's just a placeholder. So we create a read and write role here. We can see that we have a little piece of code there just to let people know that this is a placeholder for those roles that are used for application. And then we have the index level permission role. This role is what gives access to those indexes that a user is using. In this case here, you can see that those indexes have a departmental level division and then the wildcard. And then the next is the default XML. So this is the navigation specific stuff. As we'll talk about later, the best thing to do is being able to reference and using dashboards and navigations from other apps, so that you can easily point people to and manage your apps and definitions and searches in your dashboards from another app without having to maintain them across all these different departments. We do that by referencing, and the nice thing about Splunk is you can easily reference an actual search or dashboard in another environment, and as long as they have access to them, they can present them properly. The search app is not your friend. Fortunately, it cannot be disabled. Many of the features, functions, and commands actually reside in the search app as a whole, but unfortunately, the search app is a source of pain. It's a source of risk where users can accidentally store searches or alerts or dashboards, as well as the opportunity for users to share or present searches through the simply share function. It opens up to all users. So unless we have a constraint to define these users that belong into that group, there's a risk of the users thing. Now, since we can't disable them, luckily we can hide them. Hiding them prevents users from accidentally going into the search app, and subsequently, it makes it difficult for the user to, by default, share and store their searches in the search app. Dashboards. As alluded to earlier, use the work of others. The nice thing about dashboards is they can be quickly referenced and managed in one place, is that you can reference them in other departments, and so you don't have to go in and actually make changes 122 different times to a template just for your dashboard to change on all those departments. Using a single reference, you can actually manage it once and have it available for all users. Lookups. Friend or preacher? Well, it's a little bit of both. Lookups are great. They're a good opportunity to summarize data and provide access to data, particularly in circumstances where you don't want users to have access directly to an index. However, there are some constraints. Saved searches will often build lookups will run a system, so be mindful about searches that run or designed from applications, as we alluded to earlier, as they will often run for all not specific to your specific user's thing. Best bet is to create service accounts and assign those searches to those service accounts and limit those results to the restricted users and indexes. So that way your departmental level app for a user can only see a lookup that's related to them. The nice thing is you can easily overlay lookups within a departmental level app so that you can define an index once, but ultimately only the user's access to their local lookup is what they can see. Additionally, by default, Splunk does not verify permissions about writing a lookup. If you have a power user that has the ability to write or create lookups, they have the ability to edit or output the lookup. That, however, can be changed. You can set either two settings that are required to change that. One is in the limits.conf, where you can set the output permissions to check permissions. And then additionally, you need to set it on every lookup to also check the permission. So once you set both of those, your lookups will properly verify that a user has write permission to the lookup before they allow them to write. Scheduled and saved searches. Saved searches by default run as owner. This is how it's been configured forever. There's two ways to handle a user scheduled for searches. You can either A, change the scheduled searches default from the dispatch as owner to dispatch as user, or you can set in the limits.conf a setting that forces all saved searches to dispatch as user. Now this only applies to saved searches in which the user runs a search. Scheduled searches, where users have the ability to see a search that has already run, will always run as the owner. This is a requirement. The user needs to be defined who runs it, therefore this is it. So keep in mind that when you have users that run searches, and if they have scheduled searches, that where they save those searches and where those searches are accessible are appropriate for the users and the abilities to see the results of those searches. Limit the rights of users to perform scheduled searches. That way you can prevent the number of users that have scheduled searches and that instruct them and ensure that they are properly scheduling them and running them out of their appropriate role and permission. Authorize.conf features. Some additional features in Authorize.conf. We already talked a little bit about it, but here's some more. Search index is disallowed. So as we talked about before, there is a setting that we used for wildcard, where we allowed a user to explicitly get to any indexes that meet this criteria. But let's say we wanted to store an index within the same nomenclature for their department, but it's limited to security. It's a security index of some sort with data that's respective to only what security should see. We could use the indexes disallow field to explicitly disallow a specific index so that even though the wildcard allows this specific index is disallowed. This is also good for exclusions for users that might have multiple roles that you want to ensure that specific indexes are always prevented. The other one is search filter. Now, search filter is a really complicated topic on its own. It's had several talks, one of which is referenced in the title slide. I really implore you to go and check out that talk if this really interests you. But ultimately, it allows you to do per event level restrictions. However, there are a lot of exceptions. The biggest ones are that often there are many criteria that will allow for a user to see data that you would expect them to have been prevented from seeing. The best ways to, unfortunately, the easiest ways to identify this and prevent this is going to be a couple explicit things. One, that you're using an indexed extraction for the fields that you're filtering on, and that you're explicitly identifying the denials for the fields that you want them not to be able to events to see on. If you don't have those abilities to specifically restrict those events, unfortunately, search filter probably is not going to be a secure option. It might be something that you can do to prevent your average user from accidentally stumbling upon sensitive data, but don't ensure it is a method to properly secure data. Next one is workload management. Now, workload management has been around for a little while. Has a lot of really great features and a lot of great talks on it, but doesn't also have a lot of practical roles on the security side, with the exception of a couple things. However, in 8.1, they added a new feature we called mission roles. Mission roles are basically allow you to prevent specific types of searches from running based on some criteria. You might have field values or field constraints or indexes that you don't want, or maybe you don't want to allow someone to run index equals star. So you can actually write rules to prevent these types of searches to run. Additionally, you can write rules to prevent rogue searches. You can write rules to restrict certain types of searches to certain times of day. So maybe you only want extensive searches to be run during off hours. The benefit really for this is to prevent excessive amounts of resources from your systems being used, and as well as to protect your critical workloads. New feature in version 9, risky commands. Risky commands are commands that have potential risk of output. They basically modify stuff in the Splunk environment. So Splunk is increasing the security around how these commands function. By adding additional feature sets, such as risky commands, they're able to additionally control more about these outputs, more about these effects. Some of these commands include collect, dump, delete, fit, output CSV, output lookup, run shell script, send alert, send email, and TS collect. Now, some of those commands actually do need to run. Some users that are power users that might have alerts or reports or other things that they run, these things might be necessary. So you have to be mindful about how you're going to implement this. But for users that don't need these, that's potentially additional feature to secure those respective controls. Additionally, for users who create custom commands, there's a feature set called is_risky that you can add to your commands.conf stanza for your custom command to allow for those additional security controls about how those commands are. Additionally, though, when dashboards and searches run that contain risky commands, it will prompt the user prior to running them to inform them they're about to run a risky command and explicitly authorize them for running. This might be really helpful for circumstances in which you have building lookups that might require an output that are part of a dashboard or a search that a user might accidentally click on that you may not want them to automatically run. Field-based filtering, another feature in 9.0. This one is still a relatively in development feature, so keep that in mind. Things about this will probably come out as new versions do. However, there are some really nice features in Relay that allows you to filter out or filter the content of specific fields in Splunk. These fields are controlled under the role and are under the authorize.conf. The current limitation is that when you want to filter, i.e. set source types, hosts, or sources on a specific field, that you can only do so one field filter per role. So if you want to have multiple filters with multiple types of source types or sources, you'll need to create multiple roles for this. However, you can have multiple fields under one field filter, so keep that in mind. Also, field filters are designed by hierarchy, so they run from left to right, as well as role-based inheritance-based filtering. To enable role filtering, you need to add the role filtering field stanza to the search stanza in the limits config to enable. Once you enable and add the field filters, you now can add field filters -field name, as well as the setting, to specifically modify or change those respective fields. Only for raw, that it allows you to support a sed-based regex expression for replacement. This will allow you to modify the raw message from a field to the output. This is really important if you're trying to remove sensitive data from a user being able to see them. You're going to want to make sure that you update both the raw field as well as the additional fields that have the sensitive data. For fields, you can choose from the following: null, a string replacement, meaning a literal, this string will replace your string, SHA-256 or SHA-512. If you need downstream calculations, such as stats, counts, distinct counts, etc., I strongly recommend SHA-512. It's the best value for your security, as well as it prevents you from exposing any actual field values. Remember, though, there are limits. You can't filter input CSV files, so it only inputs in fields raw search data, not lookups. Also, there are a list of commands that bypass this. mpreview, mstats, tstats, typeahead, and walklux are just some examples. However, there is a setting that allows you to ensure that users have the ability or capability to run commands that bypass the filters. So you can restrict those users based on that. So keep that in mind if you need to set for those users and you have circumstances where they can run walklux or typeahead or tstats, that you ensure that you've also made sure that you filtered their ability to do such. Forwarders. You can't control what you don't control. In our environment, forwarders are managed and maintained by the departments themselves. I have no control over forwarder. I give them where to point stuff to. I tell them what to do. In our case, we do control the configurations through our deployment server, so we try to make sure that we instill that. But ultimately, the forwarder is on the box. If they want to add an input, unfortunately, Splunk does not provide an ability to say, only let this configuration apply. It's only if it overwrites it. However, there's some things we can do to help. So the biggest thing is provide a common app collection. So in our case, we provide a Windows app and Unix app. That pretty much covers the most of the base of the operating systems that most of the users will use. And you also can work with them about building out additional other services. In our case, because we use nomenclature for the deployment client config, we can easily identify devices that have services such as Tomcat or web servers, but we can quickly and rapidly deploy to them the configuration files that they need for those respective applications and services. The users can add whatever inputs they want. Unfortunately, they can send to whatever index they want. However, in 8.1, Splunk added support for the universal forwarders to send data via HEC. So HEC is Splunk's HTTP event collector. This actually adds additional level of security. HEC requires a token-based authentication. So one, now your client can be authenticated via a token. Additionally, it provides index level control. So now you can actually specify that this token from these clients can only talk to these indexes. Now keep that in mind that also may require a more complex outputs configuration as things go along in your environment. Thank you for your time today. If you have any questions, feel free to reach out to me on the user group Slack. I'm at SDBach on the user group Slack. If you're not a member of the user group Slack for Splunk, I strongly encourage you to sign on and join. Thank you. Have a great day.